G'day pals, welcome back to a new video. Today, I thought we would cover a topic following on from last week, which is custom editors, and specifically the StateTree editor / visualizer that I said that I wish I had last time. So I've gone ahead and built that now, and I wanted to take you through basically how I'm using this tool to help debug and just visualize my behavior state trees for my enemies and bosses in Insignia, and maybe just take you on a little bit of a journey about how I built that, how I designed it, and just a little bit of info about how you can build your own editors if you work in Unity. It's not a topic that I would say this is going to be a tutorial for, or at least in this episode. It's more about getting you familiar with the fact that this is possible and just getting your foot in the door about what you can expect to have to learn when doing this. So without further ado, let's just show you what I'm working with. So this is the StateTree editor. Basically, I created this from scratch in the last week. And what it does is it shows all of the states. These are the states of logic that drive the character. At the bottom end, like I mentioned in the last video, we have basically animations. And as we go up this tree, we have more abstract behaviors. So things like patrolling, if the character's in some sort of like hurt state and they're tumbling through the air, this manages all of that. And then engage, so picking different moves to use. We have this repeated charge attack, and that kind of like has a big wind up and then slides across the screen 3 times. And you can see there are 3 substates of that. And so it can get quite complicated, and this is still very work in progress. So not necessarily all of these will be in the boss, and I won't really give away too much about the boss fight, but this is a working example of the system. So the first thing I guess we should cover is the design of this system. Let me show you that. So over the last couple of weeks, I basically had finished filming the previous video, and when I published it, people were saying like, oh, why don't you just make this thing? And it seemed like a good idea. I mean, I was building a very complicated boss, and I was thinking, gee, it would be useful if I had this visualizer just to help debug and sort of see what's going on as I'm building it out. So it seemed like a pretty good time to go ahead and build this tool. I had a few requirements, and this is always where you start when you're building anything, right? Whether it's a game or any kind of software. Design should always start with requirements. So I wanted to be able to see a representation of all of the states in the tree. That's just seeing them all, really important. Secondly, I really wanted to be able to see the current branch of active states. So when the game's actually running, I want to be able to watch the state tree tick through and select the different states. Similar to how you use the Unity animator, and you can see those state transitions happen. I wanted to see that happen here. I also wanted to be able to browse the history of all active states. Whenever the states are changing, like one state every frame because they're stuck in some sort of exit loop, or if there's multiple changes per frame, I really wanted to be able to see that in an independent way of the actual play state of the app, and just be able to manually, check through the states and say, okay, what actually happened? What was the boss trying to do? And did it actually manage to do what it was trying to do? And finally, I wanted to be able to spotlight state components on click. So if I click one of the components in that visualizer, I want to be able to go to the actual component inspector that's driving that and be able to go in and check the script and debug from there. So pretty simple requirements. And I thought I would jot down just a couple of data points that I would need to store in that visualizer. Then I just went to some very early thumbnails, just doing some sort of like very early concepting of like what it is I wanted to be able to see in the window, and trying to figure out some issues that I caught pretty early, like what would happen if we wanted to draw these in a way that was space efficient. Like how do I actually make sure that it's not going off the edge? These trees can obviously become sort of like exponentially wide the further you go down. And so I wanted to be able to like at least make the most use of the space that I could. That was really important. So I started coming up with a solution for how I would draw that. And the solution here was that I would need to formally create a little data structure to contain all of the states and their depths, so that I could count at any depth. So if this is depth 1, 2, 3, how many nodes are in that depth? And that way I could actually just paint them 1, 2, 3, 4, 5, as many as there were, without really worrying about which ones were a child of who and how to lay those out. It's not really easy to lay them out if you just split evenly as you go down. Like in this case, we've got 1, so you put that in the middle, right? In this case, you've got 3, so I guess you would want to split them across. But if suddenly this guy has like 6 child states, and one of these only has 1, you need to be able to count exactly how many there are so that you can arrange them properly. Otherwise, if you give each of them, if they each inherit a third of the space, all of their children will have to be crammed in, the space that they inherited, which doesn't make any sense. All of the descendants at a certain level shares the full width. That was just something that I knew I would have to do. So just doing a little thumbnail like this made that pretty obvious. And along the way, the concept of history came up. So how exactly do I store that list of states? What actually constitutes a history of the tree? Do I have to store every single node on the way down and say that's the history? And then store one of those lists for every frame, or what? And the surprising answer here is that actually you only need to store the current leaf state, right? The deepest state in the tree that's currently active. That's the only one you need, because from here, you can't really do anything except go up. And if you just keep going up, that traces out the active branch. So you don't need to store these 4, because merely storing this kind of it implies that the others are stored, which was a really neat kind of solution. So once I had that sorted out, I mocked up a little sort of view of what I would expect things to see if I went into a history debug mode, being able to select left and right to go back through the state list, and maybe just track the time. So how long was this state in? This is as far as I was prepared to go, and I was fairly confident at this stage that this would at least get me something that was working, and then I could just keep adding features from there if they became necessary. I didn't want to overscope it, and I didn't want to spend more than a couple of days on this thing. All in all, it was 12 hours, so not so bad. So back to the editor. As we run around, you can see here on the right all those states sort of cycling, and if I parry, now you can see she goes into the stun state. She's now being juggled. She falls, she gets knocked down in the air. So yeah, it's totally functional. And if we want, we can even pause here. We can go into history and we can start cycling through. What I've got here is the number, so the index, and it's organized, from the most recent to the least recent. I've got the actual completion status of the state. So was this interrupted, or did it finish on its own accord? I have the time, and then the state name. And some of these states, I've actually got reasons. So this state finished, juggle, and it finished because it completed its juggle time, which was 0.354, blah, blah, blah. And this came up sort of as I was building the tool. I realized that it wasn't quite enough to know whether a state simply completed, because some of these states have lots of exit conditions. So I actually ended up building a little extension to my state system to report when I label a state as complete, to provide a reason. So I actually do that now. I have a little string that says, okay, this happened and that's why. And I can show you that in a little bit. And that's something that's really useful. And I didn't anticipate that I'd have to build it. So as I cycle back through this, you can see the state sort of just cycling back. And at this stage, it's pretty good. It's pretty useful. It does what I want it to do. If I click one of these, I actually go into the subtree, so I can click engage, and now I get just the engage states. And when I click this, now we're in that actual game object that's holding engage. You can see there, and I can go into it. And I can go even deeper. This is the repeated charge move, and it's got 3 different animations, and you can see which one's which. You can go up back to the total tree. So you've seen the StateTree Visualiser editor, and you know that it works, and I'm quite happy with it. You can see it does the things that I said it would do. Let me tell you a little bit about what it takes to actually make one of these. So this isn't a tutorial, again, but at least you'll have a little bit of an understanding about what you're in for. In order to make an editor for something, you need to have a class that basically serves as the thing that holds all of the UI information for that. And any class in Unity that uses Unity's editor features needs to be in a folder called editor. So this folder here is called editor, and it contains StateTree editor. So if I click this, you can see it contains all of the stuff that we need to draw the editor. So before we jump into this, I just want to make something very clear. Unity has multiple UI editor frameworks. So the most recent one looks a lot like HTML and CSS when you use it. And if you're familiar with front-end web dev, maybe that would be for you. This system, what I use, is a little older, and it uses Unity's editor GUI and immediate mode GUI libraries. So everything that it takes to draw this is in the one class. It's not very flexible in terms of its markup, but for something very simple like this, it's useful. So let me show you. To make this work, you need to be using Unity Editor, and you need to inherit from Editor Window. There are a couple of different ways you can do editors in Unity. One is an editor window, which we're looking at, and an editor window stands on its own. Okay, you can have a window open and not really have anything particular be inspected. It's just an editor window. Or you can make an inspector, and that will override the inspector window for a given object. So that can be an inspector window for a scriptable object or for any asset that you want to make a custom editor for. Now I've got a bunch of instance variables, basically just style guide stuff. So then I've got the menu item call out here. So basically this says, hey Unity, inside of the editor, inside of the window tab in the toolbar at the top, I want something called StateTree editor. And when I click that, that's going to run this function. And that actually builds the window. It creates an instance of this window. And you can see that here. If I press window, you can see StateTree editor shows up. And that just creates one of these windows. And then you can place it wherever you want in the UI and away you go. You have to have an init function. And then this function here on GUI is very similar to Unity's monobehavior update function. So, you know, in Unity, most of your components will have an update function where every frame something gets done. This on GUI is basically the same thing, but it's just for when the editor updates, which happens, you know, once every so often. It's not every frame. It's not 60 frames a second. It can depend on whether or not you're trying to repaint the screen, if the mouse is waving over it. It tries to be efficient and it tries to not update unless it has to. I've got some stuff here about whether or not we should draw the UI, what kind of mode that we're in, whether it's viewing history, whether the app's playing, that kind of stuff. And then down here, this is just me drawing the actual thing. So first I build the tree. This maintains the data structure that then we draw. And this is a recursive function. We basically go down through the tree structure in like a nested fashion to draw it. And then once we've got that data structure, we draw the tree. And this is also pretty straightforward. Basically what we're doing is we're going through all of the states by depth. It's kind of like a breadth first traversal where we just go across the tree, depth by depth, and we just draw a line and the states themselves. So we did this for every single node that there is. It has a box and then a line that goes to the box that's above it. And that's very simple, the state. I just have some rectangles and they get drawn. Earlier on, I mentioned that we needed to be using Unity Editor, and this is why. Basically, these functions here, editor.GUI.drawRect, or in this case, GUI.button, those actually handle the drawing of those components, those visual elements in the editor itself. So I'm doing a lot of hard coding for things like the layout and how things should be appearing based on counters and bits and pieces. It's not a particularly flexible setup, but I know that I only need for the editor to do exactly what I want it to do. So if I was to make some design change about how I wanted to represent these states, I'd have to rewrite this. But like I said, it took 12 hours, so it's not a big deal. And then I've just got some extra buttons. These are really messy, these functions. Basically, this is the history bar, so the bar along the bottom. I'm just setting up some variables first, how wide it should be, how tall it should be, and then showing, this is like the debug stuff. This is like the messaging that tells me, oh, the state was completed or it was interrupted. I have a reason for them ending, and I'm just printing that stuff out inside of a box. It's really straightforward. GUI.label is how I do that. GUI.button here. So that is being run every frame, that on GUI, and it's drawing this thing. And I've got little calls for things like the total width of the window in order to rescale this based on what's happening. I don't have any way to zoom or pan or anything like that just yet, and I haven't had to. Armin's tree is pretty big. Armin's tree is massive, and I guess if I was trying to debug this, it would be a little harder because he's got so many states. But that's just the way that he is. He's very complicated. He's a very complex character. You know, he's got a lot on the inside there. So you know, that's just how it is. So the last two things I want to show you are the actual data structure that I build to create this, which is kind of interesting, and those completed messages, which I think are actually really cool from a like unit testing kind of like debugging purpose that I sort of stumbled into. So inside of the StateTree editor window, I have an instance of a StateTree, and prior to this, I didn't actually have a formal structure for how I would draw this thing or represent this thing or save it in memory, something that I could traverse and access in a way that made sense for how it's shown visually. And what this does is it basically it's a tree. So you have a root node and then has child nodes, and you traverse by asking the root for its children and so on. So that's basically how tree structure works. But I also have a couple of other things. I have a hash set, which says all of the states that have been added to the tree. And this helps me avoid duplication. So I only draw a state once per component, even if a component is reused by a few different states. And I have a dictionary of the states themselves, coupled with the node that represents that state, the node that actually holds the history information and a little bit of other stuff about the visual representation of this node. Okay, so it's a fairly simple class. It really just has an add, and that's it. Now that we've got that, I just want to show you like how I build the tree. Basically what I'm doing is I'm using reflection in order to make this work. Reflection is a way in C# to ask a class information about itself. So not an instance of a class. We're not asking, for example, if this apple has a red color or has been eaten. We're asking about apples in general. What is it that apples can have? Oh, they can have colors, or they can be whatever it is, right? So we're asking information about the actual definition of a class. We know they're all behavior states, but we don't know what kind they are. And for the tree, of course, that's what we need to see. All the different kinds of things that the enemy can do. I'm using link here, and link is a way of just like navigating collections and getting sub collections of them very easily. It's kind of like a query language. So what I do is I take the very, very first behavior state that I can find on a game object, and I call that my target. And then I say to my target, let's build a subtree for you. And that involves taking a list of all of the behavior states that are defined inside of that class. So for example, Armin has ground control. Ground control has run, it has skid, it has idle. So we're looking at ground control hypothetically here. Ground control says, oh, I've got some fields in my class definition that are also behavior states. I have run, I have skid, I have idle, and those get added to a list. And then I put those in that tree, in that representation of the tree, so that I can draw them later. And then I do the same thing for each of them. I say, hey, each of those little states, do you have states inside of your class definition? And that's how I do it. So for the building of the tree, I do this. Later on at runtime, I can ask that root node to trace its active state all the way down to whichever of those children, and then draw the tree reference. So to say like, hey, in the tree, which of these little nodes represents the active state of this character right now? And then draw the line upwards from there. And you can see here, like I said earlier, we only need the bottom node in order to drive this all the way up. So once I had this actually operating, the next thing was just figuring out, like what additional things did I need to make it more powerful? So I added this little, not very pretty, but text area field, so I can go to the last state very quickly, because it made it pretty difficult, clicking through this. If there's 40 state transitions, it's a bit complicated. Since we started, playing the game, I can just jump to the most recent one pretty simply. And like I said, those reasons were actually really interesting. So like, why did this state stop doing what it was doing? And that was the creation and the addition of a new field called completed reason. Here we have the behavior state for ground navigate. And this is the parent state of any kind of terrestrial walking that any of my enemies do in the game. And even Armin, the main character, has one of these as well. And what this behavior does is it checks to see if we're allowed to be walking, and then tries to walk and move the character towards a destination while playing the walk animation. And we can be doing this until something happens. And when that happens, it's really important to know why it happened so that we can debug it. Previously, what I was doing was just setting this variable complete to true. And I still do. Most of the states in the game still have that just complete equals true. And I use that to then know that I should break out of the state and do something else. But when I was working on the system, it became obvious, like as a user of this StateTree editor, as like the level designer or the boss battle designer, I really want to know why the thing's not working yet as I'm trying to build it out. So it would be really helpful for me to know why this state finished when it finished. So then I decided, as the programmer, it's important then for me to kind of create some sort of accountability in this system. So rather than just setting complete to true, I have a function called complete, and I give a reason in a little string here. And that reason gets reset every time the state begins. It's really just another very simple addition to the class. In this case, like, there are two reasons this could end, short of like it being interrupted. So if the character gets attacked by somebody else, by the main character, then we'll be jumping into some other state, like the hurt state, independently of this, right? This just won't get run again. And we can test for that because we know that complete didn't get set to true. But if complete did get set to true, then now we have somewhere we can actually look and see why it got set to true. So I have these two conditions to exit out of this ground navigate. One of them is if the self-awareness, which is like spatial awareness of where the walls are, if there's ground, stuff like that. If the self-awareness is no longer almost grounded, so it's not even near the ground, let's say the character is like falling off a cliff or something like that, something unexpected happens, then the state breaks, and it breaks because we're not on the ground. That's the reason. Another version is, let's say we reach our destination. If we actually reach the destination, then we're finished. Of course, the information is already there, but here, this is giving me like a nice human readable way of seeing this stuff in my editor that I can then use to basically debug things when what's happening in the state tree is not matching my expectations as a designer. And actually, as I was building this system, as I was building this tool, I accidentally solved a problem that I had had in my ground navigate since like the beginning of me building the class. Originally, what I was doing is I was asking if like the character, if the path from the character to their target was walkable. And at first, that was the case only if the other character was on the ground. But if I pushed the target character up into the air, this path is not walkable, right? You can't walk from here to here because this is the middle of the air. And so when it tried to do that, it would just break out and say, hey, we can't do this anymore. But I wouldn't know that was the case. So I realized that this clause here was basically not checking correctly, or at least the criteria that it was checking wasn't correct. And rather than check the two vectors, what I really wanted to do was just check the X component of those vectors. You know, is it safe to walk in front of where you are as you're heading towards the enemy's X position, not caring about how high up they are. And yeah, so there you go. I hope that was some useful information for you. I know it's a little bit difficult. This was kind of more of a vlog than anything, but I know many of you are really interested in building tools for your Unity games. And I personally am getting a lot of value out of tools like this, especially having built so many of them now. Little ones, right? I feel like I have a lot more confidence to actually design the things that I'm trying to do because I have that visibility. And feedback between the system and the user or the programmer is so critical, especially when trying to build something as complicated as the stuff that I'm building. You know, the players will understand what's happening in a very natural, intuitive way, but they don't appreciate that designing this stuff can be very complicated. So I don't have any plans to make any like solid tutorials on building your own editors directly. There's just so many different ways to do it, and it's been done before. If you like the Bracky's channel on YouTube, I believe he has some tutorials on this. There are tons of Unity editor tutorials out there, so definitely start with those. I don't have like a great working knowledge of this system. I kind of just fumble around in the dark until I find what I need. So hopefully you can be more informed than me. I am engaged here in the comments and happy to hear your thoughts and your opinions on what I should make videos about next. So thank you so much for watching, and I will catch you in the next one. Hey pal, thanks for watching, and thanks most especially to the patrons and Twitch subs who support this channel and my game dev project Insignia. To find out more, click the links in the description below. And if you like this video, tell YouTube by clicking the like button, and then YouTube will tell me, and then I'll make more videos. That's nice. Thanks again, and until next time.